So this is an IGCSE exam question on circle theorems. It's a two-part question. We've got to work out the size of angle PQR, so that's this one here, in part A. And we've got to work out the size of angle HKJ, which is this angle here, in part B. Now before we tackle this question, let's first of all have a look at the examiner's remarks. This is an IGCSE question, so prepare for the examiner's remarks to be a little involved and complicated. I'll go through them quite briefly. So they say that in part A, it was common to see 180 degrees minus 72 degrees in the working out, but this wasn't linked to angle POR, which is this angle in the centre. Now they say it must be made clear what angle is being worked out. If we're going to award method marks. So that was a problem for them. They were able to give a mark for the correct answer, but not a mark for the method, which means they weren't given the full marks. Okay. So in part B, they say many were able to identify the right angle or opposite angles in a cyclic quadrilateral summed to 180 degrees. In other words, most students, or many students anyway, were able to see the correct circle theorems that they needed to apply. But some assumed that the quadrilateral was an isosceles trapezium, and that wasn't correct, so they used an incorrect method. Finally, there's a complaint at the end. They say there was little sign of students identifying angles using the three-letter angle notation. So this angle POR, for example. And so as I work through these problems, I'm going to be very careful to get those method marks as well as the right answer by carefully notating what angle we're working on. Okay, so let's start with part A. So part A says PQ and R, points on the circle, centre O. Angle OPR is 36, and that's marked on the diagram. We have to work out the size of angle PQR, so the angle at the top here. Now to do that, clearly we're going to have to work on this triangle first. When we get the angle at the centre here, POR, we're then going to be able to jump up to here to get the final answer. But let's start with angle PRO. So again, we need to notate the angle we're working on, so PRO. So PRO is, well, this triangle here is clearly an isosceles triangle because this is a radius and this is a radius. So we're not asked to give the reason actually in either of these parts to this question. So I'm not going to give the reason except verbally. I'm just going to write down what the angle is to start with. So we've got PRO, this is this angle here, 36 degrees. Base angles of an isosceles triangle. And now, to make it clearer, I'm going to use a different colour pen here and just mark on the diagram our angles as we're going along. Okay, so now we've got 36 degrees and 36 degrees here. This is a triangle, and so the third angle we find by the angles in a triangle summing to 180 degrees. So now we're going to work on POR. So again, very important to write down the angle you're working on. So angle POR, and you need to get those letters in the right order so that you're definitely pointing to the right angle. So this angle here. So angles in triangle sum to 180. So we're going to take 180 degrees and subtract the two base angles, the other two angles, until we get the angle that's left, which is POR. So 36 degrees is one of them, and the other one's 36 degrees. So we just add those together and subtract from 180. So now we've got 180 minus 72 degrees, which gives us 108 degrees. And just to make sure that we've got that correct, we're going to do a check as we go along. I'm going to just add that back. So 108 plus 72, well, 70 plus that 100 is 170, 8 plus 2 is 10, so 170 plus 10 gives us 180, so this is correct. I haven't made a mistake in my arithmetic. So PRO is this angle at the centre, this angle here, POR rather, POR is the angle at the centre, and again I'm going to just write that in on the diagram so I can see very clearly how I'm getting on. So I've now got 108 in the centre. And the angle in the centre, of course, is twice the angle on the circumference. You can see this classic arrow shape, so sometimes called the arrow theorem. And that means that this angle here, well, that must be half the angle at the centre. And if this is 108, half of 108, well, half of 100 is 50, half of 8 is 4, so 54. Okay. So now that's completed the diagram, I again need to carefully mark what I've done here. I'm now going for the angle PQR, so angle PQR is, what is it, 108 in half, so half of 108 or 108 degrees divided by 2, which is 54 degrees. Okay, so that completes part A. Let's move on to part B. So part B says G, H, J and K are points on the circle. So we've got 4 points on the circle now. KJ is a diameter of the circle. So KJ is a diameter of the circle. And if that's a diameter, and it's worth, in fact, let's just highlight that. If it's a diameter, then there must be a centre. And so what I like to do is just mark where the centre must be. And let's call the centre O. And that just reminds me that this is a diameter. It's not just sort of randomly going across the circle here. It is going through the centre. Okay, so KJ is a diameter. Angle KGH, so KGH is 124 degrees, so that's marked on the diagram. And we've got to work out the size of angle HKJ. Now let's be careful here. HKJ. So that's this angle here. That's our target angle. Okay, now we said this is a cyclic quadrilateral, and we should know that the angles, the opposite angles in a cyclic quadrilateral, sum to 180 degrees. So let's start by getting this angle here, which is opposite the known angle KGH. So we're going for angle HJK. And they sum to 180 degrees, so we can get HJK by taking 124 from 180 degrees. Like that. And that gives us 56. Again, just making sure that my arithmetic is correct and we haven't made a mistake here. If I add the 100, we've got 50, add 20 gives us 70, 6 add 4 is 10, so 170 plus 10 gives me 180, so I can be confident that that one's correct. So let's mark that on the diagram. And that gives us one of the angles in this triangle. Now the other one then is this angle here. So we need to now find angle KHJ. Angle KHJ. So how are we going to find that? Well, if we ignore this triangle here and just look at this triangle here, we might notice that it's a triangle in a semicircle, and the angle of this angle here in any semicircle, the angle in a semicircle is always a right angle, sometimes known as Thales' theorem. So this must be 90 degrees. If we couldn't remember that one, we do have the other way of thinking about this, which is this angle here must be 180 degrees, so that's the angle at the center. The angle at the center is twice the angle on the circumference. So either theorem can be used to get this angle here 90. So now we've got two angles in a triangle, we can go for our answer, which is the angle HKJ. So let's first of all finish this. So KHJ equals 90 degrees, or maybe we could write 180 degrees divided by 2 equals 90 degrees. Finally then, HKJ. So angle HKJ has got to be 180 minus that 90 plus 56, which gives us 180 minus 146, which is 34. Again, not trusting my mental arithmetic, I'm going to add back to give myself a check. So 100 plus 30 plus 40 gives me 170, and the 4 plus 6 is another 10, so 170 plus 10 gives me 180, so this must be correct.